Curve with equation y equals 2 ln 8 minus x meets the line y equals x at a single point x equals alpha. Show that this value is between 3 and 4. So when they meet, the y values are going to be the same, and therefore we're going to get 2 ln 8 minus, well, I'll write alpha, and that's going to equal alpha. Okay, it's just when this equals this. To show that alpha is between this range, we should use the sign change rule. So I'm going to write it as 2 ln 8 minus alpha equals 0. And then sometimes I call it like give this a name of a function like g of x and then show we're trying to basically show that it's going to be positive for one end and negative for the other end. I don't think we need to actually call it a function, but let's just say when alpha equals 3, the left hand side, focus on the left hand side basically, that is going to equal 2 ln 8 minus 3 or ln 5 minus 3 and get 0.2188. Main thing to say is it's greater than 0. When alpha equals 4, do a very similar thing. Change the 3's to 4's. Get minus 1.227. And this is less than 0. So there is a sign change. We should just say that the left-hand side is continuous over the interval. It's not like it jumps from being below the graph to above the graph. And therefore, 3 less than alpha less than 4. Okay, if I haven't gone to enough detail here, I'm just saying like basically I'm treating this as a single function now. And we've just shown that at 3, we have 0. The y value is positive, and at 4, it's negative. Because it's continuous, it's got to at some point cross the axis, and that's what I'm saying. It's because it's gone from positive to negative, there must be somewhere in between that it becomes 0, and that is our alpha. Alpha must be between 3 and 4. Figure 2 shows the graph of y equals 2 ln 8 minus x and y equals x. And by the way, where they meet is our value of alpha. The student uses this iteration formula in an attempt to find alpha using the graph and starting with x1 equals 4. So this does not mean substituting in 4 into this iterative formula. Okay, no credit for that. It says using the graph. Determine whether or not this iteration formula can be used to find an approximation for alpha justifying your answer. So it's actually asking us for some in-depth understanding of what we call fixed point iteration. Because what is happening is we're putting in 4 and you start it off by putting it in there and then you put it into you get the function out, and that is what is going to give you this y value here. And then that becomes your new value of x. Now, to make it your new value of x, you go along and actually you just hit y equals x, and that's our new value. So we now put, this is our new value of x here. We now put that into the formula again, and we go up to the function again. And this is the start of a cobweb or staircase diagram. We just continue bouncing around, and we can see in this case, it's actually going to spiral in towards the root. But I didn't quite work out that last bit, but right at the end, it's just going to kind of go in and converge towards it. And so to summarize, the answer is yes. The cobweb spirals in towards alpha. It's just a contrasting example for when you don't get convergence. So I've got my graph y equals x, but perhaps it looks like this. And if I start here, I go up to my function, then actually I'm going to go along here. And then I'm going to go up to my function, but it's just getting bigger and bigger. Maybe it goes along to here, and it basically diverges away from where the actual root is. So that would be an example of where the iterative formula, well, assuming that there was one, this is a different function, um, it wouldn't give well, using this starting value in any case, it wouldn't give the value of the root. If you started somewhere else, let's say we start here, actually we go that way, and again, you'd end up going away from the root. So basically, you need to be careful when you construct an iterative method because there are conditions for convergence. I'm not going to go into detail on it here, but yeah, it doesn't always converge. So there's different choices. Here it does, and you could put in 4. In fact, just to finish, this is not what you meant to do in the question, but we could put in 4 and then 2 ln 8 minus answer. That's my current value. Okay, when I put that in, that gives me my new x value. So I'm actually going up to here and then along. So I'm now here, this value of x, 2.77. I do it again, and I go up and along to here. So now I'm at 3.307. And now I'm within the spiral. Like, you can't see it very well. I'd have to zoom in, but you can see I'm just getting closer and closer. It's kind of jumping above and below, but I can get it to as much accuracy as I want if I just keep going. So that is actually going to be my value of alpha to, say, like 8 decimal places. Okay. Hopefully that makes sense, as well as like learning, the process of the question. I'm trying to explain what is actually going on in this fixed point iteration.